Let's pause once more to observe the original image. In the reference photograph, the point of contact between the wall and the surface appears visually coherent and natural, whereas in our test rendering there is a clear and unconvincing separation between the two elements. Let's see how to solve this problem. Let's switch back to the front view. Let's change the display mode to wireframe and set the working mode to edit mode. Before making any changes to the vertices of the wall geometry, it's best to enable the Correct Face Attributes option to avoid distorting the materials already applied. To do this, at the top of the 3D view, click on Options and check the Correct Face Attributes box. This precaution allows you to modify the geometry while keeping the shading data and texture distribution intact. Let's select the lower part of the wall's vertices, making sure not to include the first row of vertices immediately below the support plane. Click on Delete or X, and from the menu that appears, choose Vertices. Set the side view by pressing 3 on the numeric keypad. Select the bottom row of vertices. Move it along the Z-axis, keeping it slightly below the support plane line. Press GY 0.5 followed by Enter to move the vertices along the Y-axis, positioning them further back compared to the wall line. Press the keys EY1 followed by Enter to extrude these vertices along the Y-axis. Repeat the same extrusion operation once more. With this operation, we've created a bevel that allows for a more realistic transition between the two surfaces, credibly simulating the contact area. Let's return to object mode and set a perspective view that allows us to better observe the point of contact. Switch the view to rendered and, if necessary, lower the wall along the Z-axis. Just enough to achieve a visually more realistic contact with the support surface. Return to camera view to observe the result. Let's take another look at the line of contact between the wall and the support surface. In the reference photograph, a slight smudge is visible. This is typical of points where surfaces meet caused by the accumulation of dust, debris, or material imperfections. Let's see how to recreate it. In the shader editor, let's add the leaking 009 texture above the diffuse texture. Select the Mix Color node, set to Multiply mode, and press Shift-D. We make a copy of it and place it between the Brightness Contrast node and the same Mix Color node. Connect the color channel of the leaking 009 texture to the B channel of the Mix Color node we just added. Next, connect the alpha channel of the texture to the factor channel of the Mix Color node. The dirt texture is now displayed on the wall, but we need to position it correctly. Select the Edit menu and choose Preferences. Go to the Add-ons tab and type Node in the search field. Check the box for the Node Wrangler add-on. Then close the Preferences window. Select the leaking 009 texture and press Ctrl-T. This shortcut, which we just enabled in the Preferences, allows Blender to automatically add the two nodes needed to position the texture. The mapping node is what will allow us to achieve our goal. First, let's reduce the height of the texture. Within the scale parameter, increase the value of the y-axis, setting it to 5. Set the y value of the location parameter to between 20 and 25 centimeters. If you like, you can also set an x value different from 0 to add more randomness to the texture. In my case, 15 or 25 centimeters will work fine. We have positioned the texture along the support line. However, the wall shows a duplicate of the texture. To solve this problem, simply set the repeat parameter of the leaking 009 texture to click. This way, Blender will not repeat the texture. The dirt effect we've created works well, but it looks a bit faded and lacks some contrast. In the shader editor, press Shift-A and from the menu that appears, type Ramp. Click on the Color Ramp option and insert the node between the alpha channel of the leaking 009 texture and the factor channel of the Mix Color node. Thanks to this node, by moving the black slider to the right, we can further fade the dirt effect. On the other hand, by moving the white slider to the left, you can increase the contrast. Set the white slider to a value of 0.85. We are almost at the end of this process. Looking at the test render, we can't help but notice that our image appears a bit dull and somewhat flat, compared to the reference photograph. In fact, the original shows a light coming from the right, much stronger and more focused than the light produced by our area light, which is definitely less interesting. Let's fix this problem right away. Let's open the lights collection and select the right side light. In the Properties window, open the corresponding tab and set the power value to 100 watts. At this point, a parameter comes into play that is often underestimated but actually very important. This is the spread parameter. This parameter controls the angle of diffusion of the light emitted by an area light. Basically, it determines how widely the light is spread throughout the space. A low value, for example, 10 degrees, focuses the light into a narrower and more direct beam similar to a spotlight. The lighting is intense and localized. A high value, up to 180 degrees, spreads the light in all directions, creating a much softer and broader effect. This ability to control the light is essential in still life or interior photography, where you need to shape the light precisely and create targeted contrast. By default, the spread value is set to 180 degrees, and this works well for the side light, on the left, which serves as a fill light. In fact, it helps to soften the left side of the objects, preventing them from appearing too dark or in shadow. The right side of the scene, on the other hand, needs to be emphasized more. However, further increasing the wattage would risk overexposing the entire shot, making the light too overpowering. This is where the spread parameter comes into play. Let's lower it to 50 degrees. We immediately notice that the light emitted by our area light is now more focused, illuminating only the right side of the objects in a targeted way, and at the same time making the textures of the tabletop and the wall more vivid. We still need to make one last small adjustment. Compared to the original, our wall is a bit too close to the picture, so let's select it and move it along the y-axis by about 5 centimeters. Now we're ready for the final render. In the Properties window, let's open the Render tab and click on Sampling. In the Render panel, make sure the denoise parameter is enabled. Since we have a fairly simple scene that's not particularly heavy, let's set the samples to a relatively high value, in my case 4096. Scroll through the Render Properties tab until you reach the Color Management panel. Here, the settings were already defined during Lesson 8, which was dedicated to lighting. Let's open the Output tab and make sure the image file format is set to TIFF and the color depth to 16-bit. Save the file progressively. Press F12 to start the final render. Once the calculation is complete, click on Image, then Save As. In the window that opens, select a destination folder, assign a name to the file, and click on Save as Image.